All right, let's take a look at number 5. With number 5, you're trying to decide whether or not a table represents a function. And again, the major idea with a function is that everything that is an input, which is the stuff, I'll use this one here, in the x column, make sure that each item in the x column has a single output assigned to it. So functions exist just when each input has just one output. Okay, so I'm going to look at my function here, or look at my relationship and decide. And so what I'm going to notice first is that there are no repeats in the x column. So -4 is assigned to 8, -2 is assigned to 5, 1 is assigned to 8, and 3 is assigned to 2. And so in this case, since there are no repeated inputs, it's got to be a function. Now you might notice, and you might recall this vaguely, that something about repeats is a problem when you're talking about functions. So you might notice that we have 8 and 8 here for the y's, but that's okay. Repeated outputs are just fine. The important thing is that there are no inputs that have more than one output. So I'll give you an example here. Let's say that instead of this last value being 3, it was 1 again. That means 1 would be assigned to 8 and 1 would be assigned to 2. Not a function in that case because an input would have been repeated and it had different outputs assigned to it. But that's of course not the case for this one. And so it is a function. I have to give the domain. The domain is the set of inputs. Remember to use that set notation. So I'll do -4, -2, 1, and 3. And then the range is a set of outputs, and I'll do 2 because that's the lowest. 5 is the next largest, and then 8 is repeated. I don't have to write it twice. So there we go. If it was not a function, I'd have to explain why, and so I'd have to say something specific. You have to say, for instance, in the example I gave just a moment ago, the input 1 has 2 outputs or something like that. And that's just if it's not a function. Please be specific. And that's it.